All right, welcome to PyOhio. This is Greg Back. We'll be talking about best practices for Python scripting.
Thank you, man. You guys hear me okay? All right. Thank you, Ben, for the introduction. Thank you guys all for coming. Like I said, I'm Greg Back, and we're talking about some ways to make Python scripts a little more reusable and flexible, rather than just like a one-off tool for a single task. There's going to be a lot of code in this talk. I'm going to try to not go too fast, but like I said, there's going to be a lot of code. It will all be on my GitHub. I'm GTback on GitHub. And so with that, I guess we'll get going. So kind of to get started, I wanted to pick a problem that was not too easy, but not something that solving the problem is not the rule of this talk. It's kind of showing how the script will evolve to solve the problem. So we're going to I have a slide that says this. So the problem we're going to try to solve is finding the 10 words that occur the most frequently in the gauge-vary address. Pretty common problem in language processing, which isn't my area of expertise, but it seemed like a good problem to use to solve this as a subject of this talk. So to start out with, I've got a file that has the text of the gauge-vary address. So I'm just going to open a Python shell like you might do if you're trying to solve this one. You may not know exactly what you're doing, so you're just going to play around in the Python shell. One caveat that I forgot to mention, everything I'm doing is from the standard library. I'm using Python 2.7. There are a lot of tools that you can use for this. Click is a great command line library. IPython is great also for doing shell type stuff, but I'm just sticking to the standard library for now.
Can you use a bigger font, please?
Yep.
That's better, and bigger yet would be better yet.
We'll just make this really big.
That's good.
And see how this works. So to start out with, I'm just going to open this file. I'm using a context manager to handle the file opening and closing. If you're not familiar with context managers, that's something to look into. One piece of advice I received when I was preparing this talk was don't do a live coding demo. So of course I decided to do a live coding demo. I'm going to use the collections module, which is a great module for doing kind of more advanced data structures than your typical Python lists and dictionaries and stuff. There's actually a class in the collections module called counter that is great for solving this problem, but it's not so great for the stuff I'm talking about in this talk, so I'm not going to use it. I am going to use a default dictionary, which is just an improvement on the standard dictionary that kind of gives you a default value for, in this case, a word you haven't seen before. It says there are 0 of these, if you ask. So I'm just going to create a default dictionary, and then loop through my text that I read in. I'm going to clean it up a little bit. If you're actually doing text processing, you'll do a lot more things here. I'm just going to remove some punctuation and convert it to lowercase, each word. And then just say, I found one more instance of this word. Next, we're going to take this dictionary, and we're going to use something from it's a built-in function called sorted, and then an operator called item getter. So essentially what this is going to do is it's going to transform the dictionary that we have into a list of tuples, where each tuple is the word and then the number of times it appears. And then we're going to sort that in reverse order by the first item, which is the count. So now word frequencies is a sorted list of tuples. And then we're just going to write this out to a file. Again, I'm going to use context manager. And just for the sake of this presentation, I'm going to both write it to the file and also print it to the screen. That'll just make it up more obvious when this code is running. So there we have the 10 most frequent words in the Gettysburg Address in reverse order. If you're doing an actual language processing problem, you'll probably want to clean up some of the common words like the, to, a, but we're not worried about that right now. And that's it, I'm done. So now that we kind of figured out how to solve the problem in the terminal, made a few mistakes, obviously. I'm just going to, this is a bit of magic that I have that basically logs my Python sessions. I'm just going to open this file and get rid of the error. Clean up this clean up the file a little bit, add in some comments just so we're clear on what everything's doing. So here's our script.
What's this file?
Sorry?
It's a file?
It's a file called wordfrequency.py.
Okay, so you didn't touch this yet?
No, so I basically took the output from the REPL session that I
Okay.
and I just said dump this into a Python file. And then I cleaned it up a little bit. We can run this, and we get the answer that we did before. So now we have a script, and we're going to go through some of the processes for making it more reusable in different ways. Another caveat, I'm leaving out a lot of doc strings and comments and things like that, and testing and error checking. All of that you should probably put in your scripts. So like I said, you can run this with Python shell. You can also use the -m flag to Python to run a module. And I'm actually going to make this executable so we can just run it like that. I knew I have it in my notes. I avoided all the comments and stuff, but I do need to have that. There we go. Okay. So the first thing I'm going to do to this script is kind of just wrap all of the behavior in a function. I'm going to call it main because that's pretty standard. And then I'm going to just call this function. And so that's not actually going to change anything. The one thing that is kind of troublesome in this case to making it a really reusable thing is if I open a Python shell and just import, it actually runs the code when we import it. We don't want that. So the convention in Python is to add a line kind of like this. If you've looked at a lot of Python scripts, you'll probably see this. So depending on how Python loads a particular module, it'll give it this magic attribute name. And so if you import it in a Python, like in the REPL session like I just showed, the name will be the name of the module. But if you run it as a script, the name will be this string main. And so what this block is going to do is only run it if you're running it as a script, not if you're importing it into some other library. So that'll help make this module and the functionality we're creating reusable in different, in larger programs. So like I said, now if I go back into Python, it doesn't run it, but I can now call that, and now it'll run. Now we're just going to clean up this function a little bit more. I'm going to move the main function down to the bottom and split this up into different functions to kind of make the functionality more modular, and so you can reuse parts of it. So, a function called readText, and it's going to return this data. I'm going to make a function called countWords. It's going to take data as a parameter. Create a function sortWords, which takes that word dictionary that we created as a parameter, and I don't need to actually get this value, I can just return it. And then lastly, I'm going to output the results. So now the main function just kind of has to chain all those together. So now the main function just kind of reads or runs through those four functions in order, takes the results from one pass to the next. This will make it easier to later if you get data from a different source, you don't need to use that first function and so forth. There won't be any change. There won't be any change to the behavior if I run it as a script now, but you can call those functions individually. So the next problem is that I have these file names hard-coded into this file. And so maybe we want to do word frequencies on something other than the Gettysburg Address. I don't know why you would want to do that, but we should probably make that a little more flexible. So in order to do that, I'm going to read some parameters from the command line. And to do that in Python, the best way is using the sys module. Or the first way is using the sys module. So I'm going to import sys, and then this function will need to take a file name. So I'm just going to make a parameter called infile, and that's going to be the file that I read. And then the output file, I just need to add that as a parameter here, and I'm going to obviously open that and have that be the file that the results get written to. And then down in the main function, I just need to pass So the argument vector in Python, the first value is the name of the script, and then anything after that is the arguments that you pass to the function. So that's why I'm starting at 1. So now if I run this script, it's going to complain that there is no first argument. So I can do address, and I'm going to send files again to this results.txt file. Again, we're still printing them out in addition to printing to the file. But now we can actually look at other files. So I have text of Alice in Wonderland saved. And again, put that in results.txt. And so here's a completely different input file. The script no longer is dependent on that one file. I think I already showed this, but if you don't pass in the arguments, though, it's going to give an error. So maybe you don't have the text saved on your computer, maybe you're getting it from another source. In the Unix, Linux world, being able to pipe output between, or pipe data between commands is a pretty common pattern. So we're going to change the script to let you read from standard in and write to standard out, in addition to reading from files. So this is the point where I'm just going to change this to be outstream, so I'm not actually handle opening the file in this function. And I'm also going to not print it out anymore since we have it already going to standard out, or we have the option to send the results to standard out. And so now I'm just going to, so now we're just going to do some checking. Like before, we had the error where if you didn't have the arguments, it would raise an error. So we're just going to check, make sure if there is an argument, we're going to use it. We're going to reuse the sys module here, which also includes standard in and standard out. If you're reading a large chunk of data, you probably need to buffer the data somehow rather than reading all into memory at once. But we won't need that for this. Otherwise, we'll just do what we did before. And same with the output. So the first argument needs to be the input file, and then the second argument will be the output file. So in this case, if there's no output file, we want the outstream to be otherwise. We'll open a file. I took the file opening outside of the output results function. Here. And so now, it should work the same way it did before, if I don't have a syntax error. And so that works just the same way it did before. It's no longer printing the results of the screen because we took that out. But otherwise, if I remove the results file, and then I run this again, you'll see the results are in this file. This has the added benefit of being able to take input from standard in, so this obviously isn't much different. So if you don't include the result name, now it will print to standard out. And if you don't want to, or to get data into the program, you can just pass it directly to the through standard in to the file. You can also do crazy things like this. And so I just enter some text on standard in, and then when I enter the standard in, it will calculate the results for me. If I was on the internet, I could just grab the text from a web page and do the same thing with Perl or whatever. You can get data from anywhere now and pass it into the script to calculate the most frequent words. The one problem that you run into at this point is that managing this argument vector and parsing arguments that way can get kind of a pain once you have more than 2 or 3 arguments. So there's a great module in the standard library called argparse. I know a lot of people don't like argparse. I love it. I'm sorry, I'm not ashamed to say it. It works really well for scripts like this. Click, the library I mentioned earlier, works really well when you start having subcommands and things like that for your script. But for a script kind of at this level, argparse is great. This is where I didn't want you guys to have to watch me type all this out, so I will walk through this code though. So there's a function here that will create an argument parser object and add 2 arguments. So the input file and the output file have some help text in there that shows that they default to standard in, standard out. And it also uses the nargs, which the question mark means that it's optional. And the string in file or out file is the name of the variable that the argument we're going to assign to. So with this function to parse arguments from the command line, I can call that in the main function. And then I don't actually need to check the length of this. I can just say, was there an in-file argument passed to the script? So if there's not one, I'm going to read from standard in. Otherwise, I'm going to use that as the input file. Same thing with the output. I can just so one of the things that argparse is great for is it'll give you a help message that shows you what the arguments are and the help text that you put in. I still have the problem where if I don't pass an argument, it's going to be reading from standard input, which isn't what we want. And using the argument parser also makes it easier when you have other arguments, or if you're going to start adding arguments, like I said, you don't have to manually mess with the argument vector, especially when arguments can be in different order or options. So the next thing we're going to do is add another argument. The other thing that was kind of hard-coded into the script that makes it less reusable is the number of words that you're looking for. So 10 is kind of a magic number, and we want to avoid magic numbers when we can. So I'm going to add another parameter to this. To this output function, and I'm going to say, okay, I default to 10, but let you pass in a different number of arguments. So I can just really quickly add that to the argparser. Argparser uses the same syntax for command line flags and for arguments. But I'm just going to say you can pass it with C, or you can pass it with count. The type is an integer, so it will handle converting to an int. And then I'm just going to put in default equals 10 here. Now I also need to pass this as an argument to the output. So now when we run the script, I can say, give me only the 3 most frequent words indicating your address. Or I can say, give me 100 most frequent words. And that again promotes the reusability and the flexibility of making more reusable and more modular. So if you can take options from the command line, you can also take them from a variety of different sources, environment variables, config files. So the next one I'm going to talk about is the environment variables. And this could be really useful when you're like in a continuous integration script or something like that, where you may not want to be changing the command line all the time, but you can set up an environment a certain way and run the script in a different, with some different options. So I'm going to grab this other snippet. All of the environment variable parsing comes from the OS module, so I need to import that. And if I don't do it right now, I'm going to forget to.
You still need 6 in there now that you've got argparse.
Yes, because I'm using it for standard and standard out. Oh, so another big thing I'm going to do now is actually split up this main function from the actual code that's doing the work. One of the things I believe in is splitting out all the code that handles setting up your program from running the program. So here we have a lot of code mixed in that's doing getting and setting options versus the code that's doing the actual work. So I'm going to change this to word-free. And this function is going to take a count argument, an input file, an output file, and so I don't need to, these will just come from the command line, or these will just come from the function arguments, not from this arguments object anymore. What else am I using it? And so now we'll just make the main function parse the arguments. Also going to call that environment, this parse environment variables function that I just put in here. So the environment variables behave a lot like a dictionary, and so you can just call get. One of the things that I like to do is prefix all the environment variables I use with a short tag that says this is the word frequency program. It makes it easier to find environment variables and just know where they're coming from and what they're being used for. So parse environment variables, and then we just need to say the count that we're going to pass into that word frequency function is going to come from either the arguments that are passed in the command line or the environment. We want the argument to take precedence. So if you pass a count on the command line, it'll be in that args.count variable again. If it's not there, it will check in the environment. Or we'll just use the default value if it's not in either of those places. Same with the input file. And the output file. And then we can just call that function that I wrote with these three arguments. So like I was saying, this does a good job of separating the code that reads in options from a variety of different sources from the code that's actually doing the work of the function, or the work of the script. So if I did all that right, I should be able to, again, so if we just run on the user address, we get a syntax error. Oh. No, yeah. Oh, yeah, okay, I deleted the wrong thing. There we go. So now I can use and I did something wrong.
You gave a default value of 10 in the argument, so
Yep.
it's never 9.
Oh, actually, in the argument parser? Yeah, this is actually where I knew I was going to make a mistake. I've made it every time I've run through this. So the argument parser now is giving you default value, so that args, right here, this args.count is always 10, even if you don't pass it on the command line. So now if I run this, I get schema3 converts. You can also, any other way of getting environment variables,
Yeah,
I can just do, So now it's getting the results, or it's using Alice as the input file. So we have arguments from the command line. We have environment variables. Another common source of options for a program is from a config file. So there's another great class or modularizing class in Python called config parser, and so we're going to add a config parser to this program. Again, I'm going to grab this huge chunk of text so you don't have to watch me type it and make a lot of mistakes. So parse, or I can actually, I'm going to close these up. So I don't have to scroll as much. So to use a config parser, you just instantiate a config parser object. In this case, I'm going to pass in the name of the config file that I want to read. A lot of times programs will read multiple config files, so a system-wide config file, user-specific config file, or a file in the current directory. So I'm not actually going to show that, but this function will accept, you read configuration files multiple times from different locations on disk. And you would do the same thing where you say a variable in this file takes precedence over a variable in this file. Something else I was going to say about this. So once you've read in a configuration file, you can call getInt or get or just get on. It would probably help if I could show this first. So I'll do this. So the layout of these is very similar to like any files on Windows. So you can give it different sections, and then somebody pick a number. 12. I like 12. And so now, if we don't pass anything on the command line or as an argument, it's going to output the 12 most argument, because the config file is going to be the third priority. It's going to be below arguments and below environment variables. So, forgetting something. Oh, I was going to explain this code. So, once you've read in the configuration file, I think it will raise an exception. I'm not actually sure what exception it raises, but I'm kind of violating the Python rule of don't check before you do something. But I'm checking to make sure it exists before I try to read it in. And so in this case, the dictionary that I return may or may not have certain keys. So when I go down to my main function, which is reading arguments. So now the code that's retrieving the arguments will first look in the arguments, and then in the environment variables, and then in the configuration file, and it will take the first one that it finds. I need to actually parse that. And here I'm passing the name of that file that I just made. So this works for like the config parser style, any style configuration files. You can do the same thing with a JSON file or YAML or XML or anything like that. You can read in a configuration file and use that to pass arguments to your script. So now, if this all works, if I just run this, it will give me 12 words. I think that's how many that are there. So, perfect. So now we have a lot of ways of getting input in terms of files or standard in. A lot of ways to read. You can redirect the output to a new file. I don't think I actually showed that. And so now in this new results.txt, you have it there, or you can, kind of with any Linux program, you can redirect the output to anywhere you find it useful. You can sort, you can search for certain words with grep or do other things like that just by redirecting the output because we're using standard out. So we have different places to get the source data from, different places to put it, different ways to get options into the program from arguments, config files, environment variables. The last big thing that I want to show is using the return value from a program. So the Linux convention is that if the program is successful, it returns 0. If there's an error, it returns some non-zero value. I'm just going to use 1 if there was any error. Obviously, you would want to do a little more. You could do a little more with explaining the error a little bit better and helping the user figure out what went wrong. So I'm just going to use a try except block here. And here I'm just going to write the error message to standard out, to standard error. And the big caveat I have with this, because I've done this actually, just because you're returning a number from this function doesn't mean that's what the system's going to return. So this is a true story, and actually was kind of the inspiration for me writing this talk. We had a Python script that was automating some other stuff running as our kind of our continuous integration test, and we had code exactly like this, and the tests were never failing, and which is good. Normally, if your tests don't fail, but the problem is that the return value wasn't actually getting passed back to the environment, and so something had stopped working, and we're like, why, all the tests are passing, why is this not working? And so you actually need to tell Python to exit with that return code. I speak from experience, don't forget to do that. So now if I try to run this program on a file that doesn't exist, it's going to print my error message. An error occurred along with the text of the Python exception. I'm not doing the full traceback because usually tracebacks scare people. So that's kind of the last, or the second to last thing that I wanted to mention. Finally, now that we have a script that behaves well in the Unix environment, reads some standard in, it writes standard out, returns the right error code, reads config files, reads arguments, reads environment variables. I want to be able to reuse this in different projects, so I'm going to make it into a package. And so setup tools is great for this. If you're not, if you haven't done anything with packaging, making your own packages, there's a lot of great tutorials out there. I'm going to just steal this snippet that I have. There's a lot of options you can pass to setup tools. But for a script, the most important is this entry points. So entry points, it's a little bit magical and perhaps not obvious, but you need the entry points to the dictionary, and any scripts that you want to have installed get put in this console scripts key, and then the value is a list of strings, and each string is the name of the script that gets run, and then kind of the path in the Python module. So it's in the word freak module, it's the main function that we want to run. Also, you need this PyModules key to set up to show that this is a Python module that we want to install with this package. So now that we have this, now that we have this setup.py file, I can go over here. I can make a new directory. Actually, yeah. I'll just go to temp. Make a temporary virtual environment. This is hopefully will work good. I'm going to copy in the alice.txt into this directory. Actually, oh, I'm in the work environment. And I'm going to pip install okay, so I was able to install this word frequency package into this new group environment. And so now I don't even need the / to run it. It is a program now that can run in any directory on the system. And now we're back to the default behavior of 10 because we don't have a config file in this directory. So one other thing I was going to say. Oh yeah. And now that we're in now we have the package installed, we can actually go back to kind of what we were doing before. We started out in the REPL, kind of wanted to end in the REPL. You can solve the same problem as you did before. Count was the first argument. I don't have the guys. So the script is still usable just like it was when we started, but now there's a lot more flexibility in how it interacts with it. That's everything I have. Does anybody have any questions or comments or suggestions or things I did wrong?
Question way back, how did you get the output from the REPL into a file? Is there
so the question was, how did I get the REPL session into a file? I have there's a feature in Python that whenever you start up a shell, it will read a file called Python startup in your home directory. So I'll just show you that since I have some time. So this is a snippet I stole from somewhere. The link's right here. It basically uses the read line library. It will read in your history file when you start up, so that lets you do, you can, normally if you start a Python shell, it will only give you access to commands you ran in that session. So by doing this, it'll read in all your history from all your previous Python sessions, and also when it exits, it will write that out to a file. So it just writes, I have this hard-coded Python history file, that's the name of the file, and so that's where all the commands went when I ran it in the shell to start. I think this is in, this is in my dot files. Yeah. So this, if you want to see this code, it's right there. Sorry, that's pretty small, but like I said, I'm taking back on GitHub, so you should. Other questions?
Does that work with other interpreters like IPython?
I'm not sure though. IPython, I
Please-
think, will.
Please repeat the question.
The question was if it works in other interpreters like IPython. I think IPython by default will save all your history from all your sessions. I'm not sure where it saves it from a file. Any other questions?
Is that Python integrated?
I'm not sure. I forget. I have my Vim setup is strange. Yeah. I use uCompleteMe for the auto completion of variables and things like that. I forget what else I use.
Part of your process there was reading in environment variables from the server itself and then exporting it into your path and all that kind of thing. That to me seems a little atypical, kind of hard to track down, that kind of thing for debugging purposes. I guess this is a more general question for everybody, but is that something that we're seeing more people using, like environment variables, rather than using a config option in any file, rather than reading in from sysarg or anything like that? And I'm seeing that as being problematic for trying to debug later on.
Yeah, so the question was about using environment variables and being possibly harder to tell where they came from when you're debugging something.
Yeah.
So the biggest place that I personally use environment variables is in like startup scripts, upstart, doing things like that. It just, I find they read a lot better if you just export environment variables before you launch your process. You can't pass them as arguments to your command when you run it. And it would probably, out of all the options, that would probably be my third choice. But I know a lot of people do it. I think I haven't done a lot with Heroku, but I know Heroku does a lot of stuff based on environment variables. That's what I've heard. So I wanted to include that as an option. And to go along with that, that's a good point. You may not want to do all of those things, but it gives you the flexibility to say I can get options from the user in a variety of different ways. Anything else?
Larger font, please. Thank you.
I mean, this is just the same thing I was showing here. I was showing where people can find it afterwards on my doc files.